How is the artillery, in complete darkness, able to detect and destroy this enemy target? Radars like the TPS-25, a transportable battlefield surveillance radar, under certain conditions can take the place of sight. The radar's RF pulses cut through most atmospheric obstructions and darkness. In addition, this radar, through use of the Doppler technique, produces an audio signal from moving targets, facilitating target detection. The produced sound is also the characteristic signature of the type of target. Let's look at the equipment of the TPS-25. This is the radar shelter. Certain components for emplacing the antenna have been removed. This is the antenna assembly. The protective plastic dome encloses the radar antenna. There are 3 antenna mass sections used to obtain various antenna heights. This is the receiver transmitter. It also serves as the pedestal for the antenna assembly. This is the modulator. It furnishes high voltage pulses to the transmitter. And this is the accessory equipment used to emplace the antenna. Power is supplied by a PU450G generator. This generator provides 115 volts, 400 cycles, single-phase AC power. The fuel mixture for this 2-cycle engine is 1 pint of oil to each gallon of gasoline. 8 fillings of the fuel tank cap are equal to 1 pint. 2 generators are issued with each radar set. Only one is used for operation, and the other serves as a spare. Inside the shelter are the remaining major components of the radar set. These are the power supply, which provides the AC and DC voltages used throughout the radar. The coordinator. It contains the servo amplifier circuits. The radar set control contains the controls and components for operating the radar, and this is the plotting board for the map. And here's something new in field artillery radar, a loudspeaker which presents the moving target in sound. The operator waits until the antenna is completely erected before energizing the radar. A boom is used to gain the necessary leverage to erect the antenna. After it has been partially erected, the boom is removed. The antenna can be employed in 2 ways. The dome can be placed directly upon the receiver transmitter or on 1, 2, or 3 mast sections, giving it a total height of 25 feet. The additional height is important when the antenna must clear ground obstructions. The antenna must always have line of sight to the target area. During the antenna emplacement, certain pre-operational checks are made inside the radar shelter. All power switches must be off. Next check will be at the power supply. Switch is off. Then, on the radar set control, the auto manual switch should be set at the manual search position, mode 3. Having completed the pre-operational checks, the operator orders the starting of the generator. Since the antenna is completely erected and all cables are hooked up, the set may be energized. The main circuit breaker is turned on to bring power to the distribution box. The radar circuit breaker is switched on, bringing power into the power supply unit. Then the power switch is turned on, energizing the radar set. Next, generator line voltage is checked on the coordinator. At the same time, out at the antenna, another operator checks the receiver transmitter for DC voltage indications. Further checks must wait until a 3 to 5 minute warm-up period has elapsed, permitting the transmitter to be turned on. The radar controls are grouped into 3 general sections: azimuth, elevation, range. Directly above the radar set control is the plotting board. It has a movable arm with an indicator light. They respond to the action of the azimuth and range controls. The small pencil light will shine through a battle map placed on the plotting board. It indicates the position of the range gate as set on the radar set control. The azimuth handwheel also moves the antenna. Let's observe this action. The antenna can be turned in azimuth until it reaches a limit stop. Then it must be reversed and rotated in the opposite direction. When it is reversed, it can be rotated 6,750 mils to the other limit stop. This gives a full 6,400 mils azimuth coverage with a 350 mil overlap. The radar, however, cannot scan automatically the full 6,750 mils in azimuth. The width of sector it can scan automatically is determined by the sector width control. The operator may select a sector of 360 or 540 mils. The elevation controls are in the center section. By turning the hand wheel, the antenna can be elevated to plus 265 mils and depressed to minus 265 mils. The right section of the panel contains the range controls. The radar's minimum range is 450 meters. Its maximum range is 18,280 meters. The plotting board is designed to operate with either a 1 to 25,000 or 1 to 50,000 scale map simply by turning the map scale switch to the proper position. The 3 to 5 minute warm-up period has elapsed, and the radiate switch is turned on. The A scope has 4 controls: intensity, focus, scope gain, vertical positioning. The radar X and Y indicators present target location in either grid or Cartesian coordinates. There are 5 different modes of operation with the TPS-25 radar. Through use of a selector switch, any one of the 5 can be selected. The modes are automatic search, automatic range, manual search, manual track audio, manual track video. In the first mode of operation, automatic search, the radar beam is 72 mils vertically and 180 mils wide. The beam scans continuously in azimuth over an area either 360 or 540 mils wide, as selected by the operator. The range gate is 75 meters in depth. In this mode of operation, the range gate strobes out along the radar beam 900 meters from any selected range setting. The operator can change the 900-meter area simply by turning the range hand wheel. The full action in the automatic search mode is the combined action of the automatic scanning in azimuth and strobing in range. In mode 2, the automatic range mode, the range gate strobes automatically, but azimuth is manually controlled. In mode 3, the manual search mode, the operator has manual control of the radar beam in azimuth and range. Throughout the first 3 modes, the radar beam is 180 mils wide. In mode 4, manual track audio, the beam becomes 36 mils in width. Azimuth and range are manually controlled. A pronounced change occurs to the scope presentation. Instead of the normal video presentation, there's a presentation of the audio return on the scope. If the target is not gated, there will be no audio presentation. Great accuracy can be obtained in this mode. When the selector switch is in mode 5, the radar beam is still 36 mils wide, and the operator still has complete manual control in azimuth and range. However, the presentation of the scope reverts to normal. This allows the operator to view both the target and the range gate, making it easier to detect the target as it moves along. Only when the target is properly gated is an audio return from the target possible. In all 5 modes of operation, the elevation of the radar beam is controlled manually. To operate properly, the radar set must be oriented. First, let's proceed with antenna orientation. The antenna must be oriented electrically, as it has no means of optical orientation. Here's how it's accomplished. At a previously surveyed point at least 450 meters away from the radar, a simulated target is employed. Almost any moving reflective object will suffice. Even an ordinary canteen will do if kept in motion. This particular device produces a steady, identifiable moving target return echo, enabling the operator easily to detect and accurately locate it for antenna orientation. The first step in orienting the antenna is to declutch the plotting board arm. Set the radar at minimum range. Place the selector switch at mode 2 for automatic range operation. While the radar strobes automatically in range, the operator searches in azimuth by manual control to detect the simulated moving target. There, a moving target, the simulated target for orientation. Once the target has been identified, the operator places the selector switch to mode 3 for manual search. Having manual control of range, azimuth, and elevation, peak the target return. To pinpoint the exact location of target, he places the selector switch in mode 4, manual track audio. With the narrow beam, the target is peaked again. On the A-scope, the audio presentation is now visible. When the horizontal lines are widest apart and the sound is at maximum amplitude, the antenna is pointed exactly at the target. The operator declutches the azimuth orientation control, disengaging the antenna from the azimuth hand wheel, and sets the grid azimuth from the antenna to the orienting point on the azimuth counters. He then tightens the azimuth orientation control knob and loosens the lock nut. The antenna and the azimuth counter are now synchronized. Antenna orientation is completed. The next step is to orient the plotting board. The exact location of the antenna site must be clearly marked on the map. An azimuth reference line must be drawn from the antenna position. Set the range to 0 by placing the map 0 switch to the 0 position. Manually rotate the range coupling. It is located between the radar set control and the plotting board. Bring the range to 0. Place the map on the plotting board. Make sure the antenna site is directly over the indicator light and that the area of interest is in the center of the board. Secure the map firmly. Never fold the map into double thickness over the plotting board. It will obscure the light. Roll up any excess. If it can't be rolled up, cut it off. Turn the map 0 switch from 0 to the operate position. Rotate the range hand wheel so that the indicator light is placed near maximum range. Set the azimuth counter to the azimuth of the reference line. Bring the indicator light directly under the reference line using the plotting board arm control knob. Then lock it. To check the setting, run the range in and out, carefully observing the path of the indicator light as it travels along the reference line. The map scale switch is set at the scale of the map being used. The map and the plotting board are ready for operation. The final step in orientation is placing the antenna coordinates into the radar. First, set the elevation at 0 mils. Set the range at 18,000 meters. Disengage the X control knob. Disengage the Y control knob. Set the azimuth counter either to 0 or to 3200 mils as the situation requires. To avoid surpassing the limit of the counters when using grid references, make the first digit 5 and carry the correction. Set 50850 on the X indicator and engage the control knob. Change the azimuth. Set it to either 1/600 or 4/800 mils as the situation requires. Using the grid reference data for the northing coordinate of the antenna, set the figure 59300 on the Y indicator. Engage the Y control knob. Write the correction figures on the radar set control. All steps in orientation have been completed. The radar and its crew are ready for action. Now let's look in on a TPS-25 operating within an area of suspect enemy activity, assigned as a general area of surveillance for the radar. The enemy, being well behind his own lines and under cover of darkness, apparently sees no reason to be overly cautious. He is, of course, unaware that a radar is searching this very area. Inside the radar shelter, the operator has placed the radar in automatic search position. He monitors the loudspeaker and the A-scope for the returns from the scanning beam and the strobing range gate. The radar is searching the general area, but has not yet picked up the walking man. Now there, his presence has been detected. With the radar in the Mode 2 operation, the operator controls the azimuth manually. He locates the target in the center of the beam. Then to Mode 3, manual search, to position the range gate on the target. This is a well-trained operator. He knows from experience the sound from the loudspeaker is the characteristic signature of a walking man. To keep the target gated, he makes constant slight adjustments. There he goes into Mode 4 for accurate tracking of the target. The radar beam changes to 36 mils, and the scope shows an audio presentation. As he pinpoints the target, notice the horizontal lines on the scope. The A-scope and the loudspeaker help the operator track this target. The sound gave him the characteristic signature of a walking man. Now the target information is reported in location and identity. A walking man. Here's another typical mission for ground surveillance radar: observation of a critical road junction. The exact location of the crossroads is known. The operator has its azimuth, range, and elevation. He must determine only the nature and movement of targets detected. There's a moving target. Listen to the sound. The operator recognizes that sound as clearly as if he were actually at the crossroads seeing a wheeled vehicle. The operator knows just by the audio return that it is a moving vehicle, and even more particularly, that it is a wheeled vehicle. And that now it has stopped. He is also aware when it proceeds again. Remember, this is an audio signal developed from the RF return. It is this characteristic sound that enables target identification. Let's have one more example. A major road under radar surveillance. The radar is in mode 2, automatic range, strobing along the road. Mode 2 operation gives the operator manual control of azimuth, but the range gate is in automatic strobing. Remember, there will be no audio return from any moving target unless it is in the range gate. There's a moving target. Another target. That sound doesn't seem to be from either a moving man or a moving wheeled vehicle. The operator places the radar in mode 5 and determines what those targets are. Track vehicles, in this case, armored personnel carriers. The operator tracks the vehicles along the highway. Note how the indicator light shows the operator the location and travel of the moving target. It is quite easy for the operator to follow the target in this instance, simply by moving the indicator light along the highway as depicted on the map and listening to the sound. And radar, the electronic eye of the artillery, reports another enemy target. Many ground surveillance and target acquisition needs are fulfilled by the TPS-25 radar. Its capabilities and employment techniques are not limited to the few examples presented here. The TPS-25 is a transportable battlefield surveillance radar for detecting moving ground targets. Knowing its capabilities, becoming expert in its operation, may mean the difference between failure or success in battle.